So let me show you an example of where the area equals 1. So if you look at the graph on the screen, that is a uniform distribution. How do I know? Because it's a rectangle basically. It's not nice as I keep going along. It's not going up, it's not going down, it's not exponential. It's just keeping a straight line. It's uniform. So I'm going to consider the function f of x is 1 over 20 for 0 less than or equal to x less than or equal to 20. Okay, so the 1 over 20 is here, it was given to me, and 0 to 20 is here along the x-axis. So x is a real number, and the graph of f of x is 1 over 20 is a horizontal line, and you can see that, because see, this is a horizontal line, it's uniform. Okay, so since 0 is less than x is less than 20, I've got to keep I'm going to restrict anything here between these 2 points, 0 and 20. So this rectangle here, because I've made those parameters, equals 1. So again, I'm looking from this line here to here, here, and here, all equals 1. Okay. So again, if you saw this, here's how to prove it. Okay, so 1 over 20 times 0 to 20 is 20, gives me 1. So that is how I know that area is 1. It's just an easy way to go back and think of like the area of a rectangle to find that that area is 1. Okay, so suppose I want to find the area between f of x of 1 over 20 and the x-axis is 0 is less than x is less than 2. And remember, it doesn't matter that I don't have the less than with the equal sign there, because remember, when we're doing continuous random variables, that doesn't matter. So I'm looking at this little area in purple right here. So again, I'm just going to do the area again. So 2 minus 0, and then I'm going to do multiply by 1 over 20 equals 0.1. Okay, and where am I getting that again? So remember, so let me jump in here. The area of a rectangle equals base times height. And that's all I'm doing. Okay, and I'll pop it back up so you can see it better. Okay, so base times height. So this little area in purple is 0.1. That is the area that it does. Okay. So suppose we want to find the area between f of x, where 1 over 20 and the x-axis is 4 is less than x is less than 15. Okay, same thing. 15 minus 4 times 1 over 20 gives me 0.55. So the area for this little rectangle in purple is 0.55. So P of x with less than or equal x can be written as P of x less than x. Because remember, I said it doesn't matter with the less than or the less than or equals to. Okay, doesn't matter. So notice that the less than or equal to is the symbol. We can use the CDF function to calculate the probability of x is greater than x. So the CDF gives the area to the left, and the P where the x is greater than x gives the area to the right. So all we do, remember we kind of did this with binomial. So if I want a greater than, all I have to do is subtract the less than from 1. That's all you have to do. So if I go back to, let me go back here. If I go back to this picture, let me go up one more. Okay, so say I wanted, okay, so this one, go here, okay. So say I wanted that between 0 and 2, okay, so but say if I didn't want that, say if I wanted, let me do this, duplicate slide, and say I'm going to say is where it is not between 0 and 2. Okay, so remember for this one, hopefully you remember it was, so between 0 and the area between 0 is less than x, less than, sorry about that, I want to make sure it's neat, is 0.1. Okay, so to get the area not between, 0 is less than x, is less than 2 equals 1 minus 0.1 to get 0.9. So that was it. So basically, I'm going to pop it up on the screen so you can see it. This area in purple is the 0.1. This area in white is the 0.9. If I add them together, I get 1. That's all that crazy slide meant, is if I need to find greater than a dew point, I just subtract it from 1. That's it. That's all it means. It's nothing harder than that.